Let's work on some practice problem now. If you followed the 2018 FIFA World Cup, you know that there were 32 teams competing in that World Cup. How many total possibilities do we have for places first, the first place team, the second place team, and the third place team? So please pause, work on this problem, try to see which formula, which rule you should here use and apply. And after you tried your best and probably solved it, come back to see the solution and compare your solution. All right, so let's do the solution. So here we have a total of 32 teams. So N is 32. We have 32 different items or teams here. Okay. What we want to do here, we want to see how many teams, how many combinations can we have, or how many arrangements, how many possibilities can we have for first team, second team, and third team. So for first team, how many possibilities do we have for first place? 32 possibilities, right? Out of the 32 different teams, we have 32 possibilities for the first place, but only one team can become first place. So after one teams become first place, how many teams, how many options do we have for the second place? 31, right? 31. And only one team can become the second place. If we have one team at first place and one team at second place, how many options or possibilities do you have for the third place? 30 teams or 30 options. So here, the total possibilities would be a multiplication of this. 32 multiplied by 31 multiplied by 30. Okay. Do you know what rule should we use? Do you remember? So this is actually example of we have three positions, or we want to actually pick three different arrangements out of 32 teams. So K here is 3, and we need to use the permutation rule. This is the formula for permutation rule. So that would be permutation of N, here is 32, and K here is 3. Permutation of 3 out of 32. And that would be 32 factorial in the numerator and 32 minus 3 factorial, which is 29 factorial in the denominator. To solve this, you need to expand the numerator. So that would be 32 multiplied by 31 multiplied by 30 multiplied by 29 factorial. And we stop right here because we can actually cancel out the 29 factorial in the denominator and numerator. So that would be 32 multiplied by 31 multiplied by 30, which we have it here, right? All right, and that's going to be a big number. That's a total of 29,760 different possibilities. All right, next practice problem. Stewie has 10 different books and he wants to put them, all of them, on the bookshelf. What are the total number of ways that he can arrange these 10 books on the bookshelf? So please pause, work on this problem, try to solve it and see what formula or what rule should you use, and then come back to see the solution. All right, so let's see the solution. So here we have a total of 10 different items or book here, and we want to arrange all of them in a bookshelf. So that's how you find the question would be in abstract would be finding different arrangements of n items, which is actually the factorial rule, right? So the factorial rule, so it would be n factorial. Here we have 10, so it would be 10 factorial, which means 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 and up to 1. Okay, 10 factorial. And another way that you can look at it is like this. When you want to put the book on the shelf, one of the books would be the first book on the shelf from the left side. The second book would be here, the third book would be here, fourth book here, and so on and so forth until the 10th book. Right? How many, so for the first position here, for the first here, how many different objects, different books can you have? How many options do you have? You have 10 options. For this, and you put one book here. For the second position, you have 9. You have 8 then. So that would be a total of multiplication of all these numbers, which is 10 factorial. All right, so let's work on the next practice problem. Stewie has 10 books to put on a bookshelf. He has all the series of Harry Potter. He has 2 identical copies of the 7th volume, The Deathly Hallows, and 3 identical copies of the 5th volume, The Order of the Phoenix. How many ways he can actually put these books on the bookshelf? So please pause, work on this problem, and try to see which rule and which formula should you use to solve this problem, and after that come back to see the solution. All right, so let's see the solution. So S3 has 10 books, but these books are not all different from each other. He has all the 7 volumes of Harry Potter. The first row is the volume, and the second row is the number of books that he has from each volume. So for the first volume, he has 1. For the second, he has 1. For the third, fourth, sixth, he has 1. But for the 5th one and for the 7th volume, he has 3 and 2, respectively. So this would add up to 10 books, but not all of them are different from each other. These 3 are similar. These 2 are also similar. So to solve this problem, we need to use the partitions rule here because we have similar items here. So you can consider the volume as groups. So we have group 1, group 2, group 3, 4, 5th, 6th, and 7th. We have 7 groups here. K1 is 1 here. K1 is 1. K2 is 1. K2 is 1. K3 is 1. K4 is 1. K5 is 3. K5 is 3. K6 is 1. K7 is 2. Okay. And then we're going to use this formula to find the number of arrangement that we can have here. So you can forget about this part. You don't have to worry about this part. Just focus on the second part here, this part. So let's see. This would be equal to n here is 10, so it would be 10 factorial divided by, we have all the k's are 1 except for the k5 and k7. So and 1 factorial is just 1, so I'm just going to ignore them. I'm just going to put 1 here, and then I'm going to put the 3 factorial for k5 multiplied by the k7 which is 2 factorial. And then you can use a calculator to solve this, or you can expand the 10 factorial to get to the 3 factorials and then cancel out each other, and it's going to be a big number. So if you solve this, it's going to be equal to 302,400. It's going, as you see here, it's going to be a big number. All right, if all the books were actually different, 10 different books, then it would be 10 factorial. It would be even a big number. Actually, it would be 12 times this. All right, next practice problem. There are 8 members of a team. How many ways are there to select a leader, an assistant leader, and a coordinator? Please pause, work on this problem, try to see which rule should you use and which formula, and after that come back to see the solution. All right, let's see the solution. So here we have 8 different people, n is equal to 8, and we want to pick 3 people, k equal to 3, to make a leader, to select a leader, assistant, and also a coordinator. So we have 3 positions here: leader, assistant, and coordinator. So if I pick 3 people here, for example, I pick Bill, Jack, and Margaret, then these 3 people can actually make not just one leader, assistant, coordinator arrangement. It's going to be more. For example, Bill can be leader, Jack can be assistant, and Margaret can be coordinator. Or Bill can be a coordinator, Jack can be assistant, and Margaret can be a leader. In fact, there would be 3 factorial, which is 6 ways to have a leader, an assistant leader, and a coordinator out of these 3 people: Bill, Jack, and Margaret. Right? So here, the order of these 3 people matters because the position that they gonna get are different. The order matter: leader, assistant, coordinator. Right? So this is an example of permutation. This is a formula for permutation. Okay. So let's solve for this. So the permutation of n is equal to 8 would be 8 and 3, and that's equal to n factorial, which is 8 factorial here, divided by 8 minus 3 factorial, which is 5 factorial. So to solve this, we're just going to expand this numerator to get to the denominator, which is 5 factorial. So 8 factorial is 8 multiplied by 7, multiplied by 6, multiplied by 5, multiplied by 4, multiplied by 3, and 2, and 1. But I'm just going to stop at 5 factorial. So now I can cancel out the 5 factorial in the numerator and denominator. And I would end up with 8 multiplied by 7 multiplied by 6. So the other way that you could look at this is, okay, you want to select a leader here. How many choices do you have? You have different 8 people. So that means that you have 8 options here, 8 choices. So you're gonna pick one of them. Only one of them can be a leader, right? So if you pick one person here, you will be left out with 7 people. So you have 7 options for assistant, and you're gonna select only one of them as assistant, and you're gonna end up having 6 people here. So your choices would be 8 multiplied by 7 multiplied by 6, which is same as what we get here. All right, so this is how we can solve this problem. And this is actually equal to 336. So there are 336 different arrangements that you can have: a leader, an assistant leader, and a coordinator out of 8 people. Next practice problem. 4 members of a group of 10 people are to be selected for a team, to make a team. How many ways are there to select these 4 members? So what this means is we have 10 different people. We want to make a 4-member team. So we want to select 4 members out of these 10 people and build a group of 4 or a team of 4. How many possibilities do we have? So please pause, work on this problem, try to see which formula, which rule you should use, and after you solve it, come back to see the solution. All right, so let's see the solution. So here we have 10 different people, and we want to pick 4 people out of these 10 and put them in a group. So suppose that I have picked Bill, Jack, Margaret, and Sarah. How many team or group can I make with these 4 people? Only one. I can put all of them in one group, and that would be one team, one group. So the order of these people in this group doesn't matter, because it's not that like we distinguish these people from each other as a member. All of them are members. It's not like one of them is a leader, one of them is a coordinator, one of them is assistant, or etc., etc. So this is unlike the previous example, previous practice problem question that we had. We only can make one group, one team out of these 4 people. This is an example of combination rule. So we need to use the combination rule to solve this problem. So let's put it in the formula. So combination of 10 and 4, or we also can read it as combination of 4 out of 10. We also write it vertically like this. We put the smaller number 4 in the below and 10 the larger number above. So this is also called combination of 4 out of 10. And it's equal to 10 factorial in the numerator and 4 factorial in the denominator multiplied by 10 minus 4, which is 6 factorial. So to solve this, you can use a calculator, or you can expand the numerator 10 factorial so that you would get 6 factorial, so you can cancel out. So basically, you have to find a way to cancel these out. All right, so let's do this. So 10 factorial, I can write it as 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 factorial. And I have 4 factorial and 6 factorial in the denominator. So I can cancel out 6 factorial with 6 factorial in the denominator. Then I have to expand the 4 factorial in the denominator. I'm going to write it as 4 multiplied by 3 multiplied by 2 multiplied by 1. And now I have to cancel out these values with the numerator. So I'm going to cancel out 4 with 8, and that's going to have 2 remains in the numerator. I'm going to cancel out 3 with 9, and I'm going to have 3. And then I'm going to cancel out 2 with 2 here. So what I have left with is 10, 3, and 7, which is equal to 210. So there are 210 different teams, 4-member teams or 4-member group that I can make within 10 different people. This problem. If a coin is tossed 7 times, how many different number of outcomes are possible? So we have one coin, we toss it 1 time, 2 times, 3 times, 7 times. What would be the possible outcomes for this 7 tossing of a coin? So please pause, work on this problem, try to see how you can solve it, and after that come back to see the solution. All right, so let's see the solution. So here we toss a coin 7 times. Each time we toss a coin, there are 2 possibilities. It's either going to be a head or a tails, right? So there's only these 2 possibilities for each time that we toss a coin. So, and we are doing it 7 times. So here we can actually use the multiplication rule because there are 2 possibilities here for the first tossing, for the second tossing 2, for the third tossing 2, and so on and so forth. So it's going to be 7 times 2 multiplied by 2 multiplied by 2, which is equal to 2 power 7. And that's equal to 128. So there are 128 possibilities when you toss one coin 7 times. Next practice problem. Suppose we have 7 identical coins and we are tossed them all at once. How many different numbers of outcomes are possible? So here we have 7 identical coins. They are not different from each other. You cannot distinguish them from each other. And you toss all of them at once. How many possibilities would be for the outcome, different outcome that we'll get? All right, so please pause, work on this problem, try to solve it, try to see which formula you can use or if there is any formula for this, and then come back to see the solution. I have to warn you that this is a little bit tricky and challenging to solve. All right, so let's see the solution. So because the coins are the same, you cannot distinguish them from each other. So when you toss these 7 coins, the only way that you can report it, if you want to report it, you cannot say, okay, the first coin or the blue coin or based on the color or the size, There is no way that you can distinguish them from each other. So the only way to report the output to someone else, or for example to me, it would be, okay, how many heads and tails that you get, and only actually you need to tell me how many heads, for example, that you get. Because if you get, for example, 3 heads, that means that you get 7 minus 3, which is 4. You get 4 tails, right? If you get 2 heads, that means you got also 5 tails, right? So the way that you can solve this is to see how many different heads and tails that you can get. So for example, you can get 7 heads and 0 tails, 6 heads and 1 tails. So these all would add up to 7, 7, 7, 7, 7. You can get 5 heads and 2 tails, 4 heads and 3 tails, and up to you get 0 heads and 7 tails. If you add these up, it's going to be 8, because you have 0, 1, and then 7 here. So that's a total of 8. So there are 8 possibilities for this, 8 total possibilities for this. This might actually surprise you, that why is this different from the previous example? Because these coins are identical. And when you want to report the output, the only way that you can report it is, okay, how many tails and heads you got. On the previous question that we tossed one coin 7 times, so we had these times that we can distinguish them from each other. So for example, we could say, okay, the first time you get a head and a tail, the second time you get a head or a tail. So you can distinguish the 7 tossing that you had from each other. Here you have 7 coins that you toss them at once, and there is no way that you can distinguish. The order doesn't matter. There is no way that you can distinguish from the heads and tails of each coin. So that means the order doesn't matter. Unlike this example that we have previously. So here the order would matter. For example, if you get for example 5 heads here and 2 tails in this example, this is only one way it's possible. But for the previous example, you could have, for example, a tail here, a tail here, and the rest of them would be heads, 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 heads. Or it could be like this: a tail the first time, a head the second time, a head the third time, a tail the fourth time, and then all of them heads. So as you see here, you can actually have different outcomes for the same possibility that you would have here. You would have it differently more when you toss one coin 7 times, because you could distinguish from each of these scenarios from each other. Here it only would count once, and in the previous question it would count actually multiple times. Or let's see another example. So for example, here there is only one way that you can get 6 heads and 1 tail, right? It's just one way that you can do that. 7 heads and 1 tail. But on the previous question that you can distinguish from the order, there was like order. So you could have, for example, 1 tail here and heads here. So this is tail the first time, heads the second time, heads, heads, all heads. Or you could have, for example, a heads the first time, a tail the second time, a heads the third time, and all of them heads. Or you could have a heads the first time, a heads the second time, a tail the third time, and the rest of them heads. So as you see here, what we counted at only one scenario, which is getting 6 heads and 1 tail here, when you could distinguish these 7 order from each other, there was order, as is we have in the previous question, there would be multiple outcomes. Where did you get the 1 tail? Where did you get the 6 heads? Was it the first time, the second toss, the third toss? So there is order that we don't have it here. So that's why we get actually a lower number. We only got actually 8 possibilities, a total of 8 possibilities, unlike the previous question. Next practice problem. We toss a coin. If it's a heads, we toss a dice. If it's a tails, we draw a card from a deck of cards. How many different number of outcomes are possible? So please pause, work on this problem, and then come back to see the solution. All right, so let's see the solution. So here we have a coin. We toss the coin. If we get a heads, we could also get a tails. So if we get a heads, then we're gonna toss a dice. Dice. How many possibilities we have for dice? It could land up to 1, 2, 3, 4, 5, or 6. Right? So there are 6 possibilities outcomes. If the coin land to a tail, then we're gonna draw a card. How many possibilities do we have for card? There are 52 different cards, so there are 52 possibilities. I'm just going to number it. 1, 2, 52. So there are 52 possibilities. So the total number of possible ways here is actually 52 if you get a tail and 6 if you get a dice. So that would be 6 plus 52, which is 58. You might be wondering, why didn't we multiply here, like a multiplication rule? The reason for that is in the multiplication rule, for example, we want to go to a restaurant and we want to go to a park. So we have, for example, 3 options for a park and 6 options for a restaurant. Then you multiply 3 by 6. But here, when you toss a coin, you either going to have a heads or a tails. You cannot have them both of them. So you cannot multiply. So when it's a or, you can have a heads or a tails. Or for or, you're going to add up. When it's a and, then you're gonna multiply. So for example, when I say, okay, you're gonna go to a restaurant and you have 6 possibilities for a restaurant, you can also go, and you want to also go to a park and you have 3 options. So you want to go to a park and to go to a restaurant. So that's why we multiply 3 and 6. We multiply by them. But here you can either get a heads or a tail, or, and since it's a or, both of them cannot happen. So we add them up here.